Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in the previous few lectures we have been discussing Pandas. So, let us start from the point where we stopped in the previous lecture. So, we are talking about arithmetic between objects with unmatched indices. So, what happens in those scenarios? So, let us focus on some of those things. So, for matched indices, wherever we are dealing with two objects and certain indices are going to be matching, overlapping. So, for their operation would be applied, but there would be certain indices which are present in one object but are absent in another object, or present in the another object and absent in the first object. So, in those kind of unmatched indices, a union of unmatched indices is created and NaN values are filled in those places. So, let us take an example. So, we will create this series 12, define this series 12 object here. We will use the PD series function and can see the values and indexes here. So, if I run this, this is the series 12, and let us take another one. So, series 13, let us create another one, series 13 here, and this is series 13. So, you can see you can compare output 331 and 333, and you can see that the series 12 has 4 row indices A, C, D, E, and series 13 5 indices A, C, E, F, G. So, few indices are common, few are not common, and of course, the values so, if I apply an operation like series 12 plus series 13, then wherever the indices are matching, we will have the sum total of those two elements values. So, if I run this, so you can see for A you can compare. A was present in both, so therefore 7.3 minus 2.1. So, we got 5.2, but the places where the that particular element is missing in one of the series object, there will get NaN. So, in this fashion, whenever we are encountering unmatched thing and we are performing certain operations, this is how it is going to be dealt with. So, DF5 data frame, and let us take DF4 data frame, and you can see row indices are matching ACD here. So, if I reindex DF4 and I insert one more row here, one more index here. So, DF4 would be something like this. Now, if I now DF4 and DF5 they will have one row which won't match, this is the row B. So, if I apply DF4 plus DF5 and look at the output, B is there and NaN is there. So, in this fashion, whenever the indices are not matching, the output is going to be generated. Now, we can also fill values whenever unmatched indices are involved, we can fill those values. So, we can fill NaNs let us say with zeros. So, for that we can use this fill underscore value argument that is available in add method, because essentially till now we talked about the we were adding these objects. So, let us say df4 dot add, and we are adding this with df5, and we can say that in the argument fill underscore value as 0. So, so in this case will have that kind of output. So, if I run this, you can see here in the output, but if you look at the row number B, all the values are still NaN. So, it did not work. So, why it did not work? Because the DF4 it had NaN value. So, the original data frames that we are using, they should not be having NaN values for it to work. It is only because of the operation that the NaN values which are being produced, they are going to be filled with this particular approach. So, let us take another example. So, in this what we will do, we will fill DF4 values 1 to 2, that means that particular row second row, and fill it with value 2. So, you can see DF4, now DF4 has changed. Now, I apply again the same thing, DF4 dot add DF5 comma fill underscore value 0. Then even though I have unmatched indices, now in this case in this case those values are going to be filled. Let us move forward. Let us take another operation, 2 divided by df4 here. So, in this case we will have these kind of values. We also have a div method here. So, we can call this df4 dot div and pass on the value 2. So, another output here in this fashion. We have RDIV method, which is div with arguments flipped. So, when we use the division operator, the slash operator there, so instead of that we can also use RDIV, which will achieve the same thing because the arguments are going to be flipped. So, this is another way to achieve the same thing. Now, let us move forward. Now, we will talk about another aspect, which is about arithmetic between data frame and series. So, there are certain similarities, as you might have noticed, in data frame and series objects, and so how the arithmetic thing will work out. So, data frame and series, they can be considered similar to 2D array and 1D array. So, that is the scenario here. So, we will pick 2D array and 1D array to demonstrate this. So, let us initialize this. Let us see first how this thing works out in array objects. So, let us initialize array ARR object, and you can see this is a 2D array here that we have defined. Shape also you can see 3 cross 4, and if I look at one of the array 0, if I look at array brackets 0, then this becomes a 1D array. You can look at the shape, just one dimension with 4 elements. So, if I perform a difference between 2D array and 1D array, so let us see what is the output here. So, array minus array brackets 0. So, we are differencing a 1D array from a 2D array. So, you can see the output, and you can see all the elements that were there, all the rows that were there in 2D array. A difference has been taken, and subtraction is performed once for each row. So, you see this is a kind of broadcasting has happened. So, where for each of the row in the 2D array, 1D array has been subtracted in each of those rows. So, you can see a kind of broadcasting has happened. So, if you look at how the differencing happens in 2D array and 1D array, probably something similar will happen in case of data frame and series. So, now let us take an example DF4, and let us take the first row here in DF4 as a series. So, this is our row here. You can see index corresponding to row index A. Now, if I perform this subtraction, DF4 minus this series 0 underscore DF4. So, a broadcasting will happen here again if I run this, and a broadcasting here has also happened. So, in data frame, each of the row they have been subtracted with the series. Now, let us move forward. Again, coming to unmatched indices here. As we said, a union of unmatched indices with NaN values kept. So, we will take another example here, series 14. So, these are the values. Now, if I add DF4 with this series 14 here, now this is this series 14 here. So, you can see that what will happen is, because nothing is matching there, so another another is going to be added here. So, DF4 plus series. So, wherever the value is present, that value is going to be added. Otherwise, you can see here the indices that we have in the series Delhi, Hyderabad and Bangalore. So, Hyderabad is not present in DF4. So, that particular column is going to be created, and Mumbai is also unmatched. So, Mumbai is not present in the series 14 and Hyderabad is not present in DF4. So, those two columns become the unmatched. So, in this case, if I add this, so we will get this kind of response. Now, let us talk about the broadcasting over the columns. Till now we have taken broadcasting over the rows. So, we can use various arithmetic methods for to perform this. So, for example, sub method we have, which can be used for subtraction. So, match will match index axis and broadcast over columns. So, let us take this series 15, which is nothing but we will define this with using Mumbai column in DF4, and this is series 15 as you can see, and this is DF4, and we can call this method df4.sub, and we can pass on this series 15, and we can specify x is index, x is equal to index, and the broadcasting will happen over column. So if I run this, you can see the values Delhi, Mumbai, Bangalore along the columns they have been changed, because broadcasting this time happened over the column. Now let us talk about another important aspect of this Pandas applying functions and method. So first we will start with NumPy element wise array functions that we have discussed before also. So let us take df4 as an example here. You can see the output. Now we will call this function np.abs. So you can see that we are passing on, just like in np.abs the numerical the NumPy function, we used to pass on 2D array and other arrays. Here we are passing df4, which is also 2 dimensional. So absolute value for each element is going to be computed. So NumPy functions are going to work well here. Now there are certain DataFrame methods also available, so we can use them also. So for example, apply method. So what is the role of apply method? So this particular method can be used to apply a function on all columns or rows. So let us take an example. So let us define this function f using lambda keyword. So this is nothing but difference between maximum value and minimum value for a given series, let us say. So difference between max and min value of a series. So let me define this function f. Now what we will do, we will call this function, this method df4.apply, and we will pass on this f this lambda function here, and this would be applied in each of the series along in each of the series along the column here. So if I run this, you can see that max and min values difference of that has been displayed in the output. You can see for the daily column 6 minus 0, Mumbai 7 minus 1, and Bangalore 8 minus 2. So the same output has been displayed here. Similarly, we can also broadcast over the rows. For that, we will have to specify this axis keyword argument here. So axis will have to specify as columns, and then we would be able to apply the function f over the rows. So we can call df4.apply, and we can pass on the arguments, and you can see the output here. Now let us talk about another DataFrame sum method. So here if I just call df4.sum without any arguments, then we will be producing column sum. So column wise we will be generating sums. So let me run this, and for each of the columns Delhi, Mumbai, Bangalore, we have got the summed up value. Similarly, if I specify in the axis keyword argument here and column, then we'll obtain the row sums here. So along each row will be able to obtain sums. So if I run this, you can see the output. Similarly, there is another important method, mean method. So this is also DataFrame method. So again, for this one also, if I call like df4.mean without specifying the axis, then it will take the column means. If I run this, by default it will take the column means, and if I want to take row means, I will have to specify axis equal to columns, and we will get the row means. Now returning multiple values using series, so that can also work. So let us take example of this function f1, which using which we will be returning such a series. So you can see in the return statement what we have, pd dot series x min comma x dot max. So we are returning multiple series, and with the index also min comma max. So this series object we are returning. So let me define f1, and we can apply this f1 on this DataFrame df4 using the apply method. So if I run this, you can see the output. We have two row indices, min and max, and for each of those columns those particular values have been returned. Now let us talk about some of the Python methods, the element wise Python methods, which can also be used on these DataFrame and series objects. So to demonstrate this, we will take this example where we want to compute a formatted string from a floating point value. So, for this we will be applying this apply map method, and to demonstrate this we will create this lambda function f2, where if you look at the expression here, we are just formatting the value in a string formatted string percentage 0.2 up to 2 decimal point, and then we are calling this apply map method and passing on this lambda function which is going to be applied. So, if I run this is again element wise. So, all the elements present in the data frame, and you can see that earlier the default output that we typically had, we had just 1 decimal point here, now we have 2 decimal point here. Similarly, we have a map method for series which achieves the same functionality here, just like apply map for data frame. So, we can call df4 and within brackets daily. So, this is a series, and we can call this method dot map and pass on f2, and the same kind of operation would be applied. Now, let us focus on another important operation, sorting. So, sorting by index. So, for this we can perform this by using a sort underscore index method. So, by default when we use this method we get the ascending ordering. So, lower value comes first and then followed by comparatively higher values. So, let us take the example of this series 16. Here we have 4 values 4 7 minus 3 2, and you can see the index also. So, let me define this and the series 16, and we can call this method sort underscore index. So, series 16 dot sort underscore index, and let us have a look at the output. So, you can see the indices, they were D, A, B, C. Now, these indices have been sorted, and you can see in the output 378 A, B, C, D. So, the index have been the indices have been sorted in this output. Now, let us take an example of a data frame here. So, this is our data frame. So, here also you can see that column indices and row indices, they are not sorted. So, again we can call sort underscore index method to sort those indices. So, df6 dot sort underscore index, and you can see by default we do not specify the axis, then it will sort the row indices. We specify the axis which is in the next example, it will sort the column index. You can see A, B, C, D. Now, as we said that the default is ascending. So, we have a keyword argument also to change that. So, we can specify ascending equal to false. So, we will get the descending order here. So, if I apply again df6 dot sort underscore index, let us say on axis 1 column index ascending false. So, instead of A B C D we will get D C B A. So, if I run this, so descending ordering sorting has been performed here. Now, that was about sorting in indexes. We had 2 indexes, row and column index. Now, let us talk about sorting by values. So, the values of these object series and data frame, how they can be sorted. So, we have this method sort underscore values method, and typically if any NaN values are present, they are going to be kept at the end. So, let us again take the example of series 16. We will call dot sort underscore values method, and you can see values have been sorted minus 3 2 then 4 7. Similarly, for the data frame, let us define another data frame df7. This is the data frame, and we can call this method sort underscore values, and there we can specify the column that we would like to use to perform this sorting by values. So, for this we can use this by keyword argument. So, by equal to B. So, B column we are picking here. So, the values in that particular column B are going to be sorted. So, sorting is based on that. So, you can see, have a look at the output. So, other things they are automatically aligned. Similarly, we can do the sorting using multiple columns also. So, in this method sort underscore values and the by argument that we have, we can pass on a list of column indices to perform this. So, in this case these two column A comma B. So, you can see first we had specified A column. So, first sorting is done by using values of column A. So, you can see 0 0 1 1, and then within that those smaller groups 0 0, the second column is used to perform. So, minus 3 4 comes first. Now, you can see then for as per the column A we have 1 1, and column B within that a small group 2 comma 7, 2 and 7. So, in this fashion, this whenever we are using multiple columns, this is how the sorting is going to be performed. Now, sometimes we might be required to perform be required to evaluate ranking. So, for that we have this rank method. So, here also the default ordering is ascending ordering. So, lower value it will be ranked 1, and so let us take an example series 17, and you can have a look at the values. So, 7 minus 5 7 and all this. So, if I call the rank method on this series 17 dot rank, and if I run this, and you can compare the output 388 and output 389 here, and you can see that the highest value the lowest value was minus 5 for the index 1, and that has been given rank 1 because the default ranking is ascending. So, the lower value lowest value has been given the rank 1 here. So, we can always change that using the ascending argument. Now, another thing which is about breaking ties using order of listing. So, if you look at the output 389, there are index row index 0 and row index 2, we have the value 6.5 as the rank. So, there a mean of the same value is there, then the mean rank is provided. So, if we do not want to perform that, we can implement another way of breaking ties. So, in that one example could be we can use order of listing. So, whichever is listed first will give that will rank that particular element first, depending on whatever it is ascending or descending ranking. So, let us take this example series 17 dot rank, and we are changing this, we are calling this keyword argument method, and we are indicating first. So, first come first serve thing, and the ranking would be given as per that. So, if I run this now, if you look at the output 390, then the row index 0 it is now ranked 6, and row index 2 it is now ranked 7, and both had the same value. So, because row index 0 came first, so it was ranked first, so it got 6, and row index 2 came after that. So, but despite the same value it got the it was ranked later, so got 7. So, now we can as I said, we can specify, we can use the ascending keyword argument and specify the order of ranking, and in this example we are making it false. So, now we will have the descending ranking based on the values. So, if I call this here, so you can see that now you can see that rank index 0 it is given the rank 1 because it had the highest value. So, you can see how the output has changed. This is our DF7. So, you can always compare. Now, we can also perform the ranking so ranking is if DF7 if we use a data frame like DF7, and so how the ranking can be done on a data frame. So, we do not specify anything in the arguments part. So, we just call DF7 dot rank. So, the ranking would be performed along the column and by comparing row elements. So, if I run DF7 dot rank, so you would be able to see the output that the highest value was corresponding to row index 1, and that has been ranked last 4th. So, because the default order is ascending. I can specify the change the axis. So, if we want to compare along the row by comparing column elements, so we can change axis equal to columns, and you can see that along the row index 0 rank 2 and 1 have been given based on the values. So, you can see that. Now, sometimes what might happen that our axes might have duplicate labels, they might not have unique axis labels. So many pandas function they actually require unique access labels for further processing, but not all of them. So we'll talk about few examples. So let's take this series 7 object here, and how do we check uniqueness? We can call this is underscore unique property here. This is a property of index. So we can call series 7 dot index dot is underscore unique, and this will tell us whether the index that we have is unique or not. So that is how to check the uniqueness. Now if we want if we want if you want to access elements with non-unique indexes, where non-unique indexes are there, then see how the output is displayed. So let's say series 7 and let's access alpha. So just one index is there with this value, alpha value. So if I run this, so a scalar value is written, just one value 1.3. Now if I access beta index, and there are two values with beta index. So therefore you can see that if I run the next line, for example, a series has been returned because there were two values. So the returned, what is being returned, if we are dealing with non-unique indexes, so the return value can become complex, in a sense in one scenario we are getting scalar value, in another scenario we are getting series object comprising all the instances. So it might create slight complexity in our code for a particular problem. So now let's talk about the same thing for a data frame. So let's take this df8. This is the data frame, and if we take df8.loc and try to access this index b, row index b, you can see row index is coming twice, row index b, row index with value b is coming twice. So if I try to access one of them, so you can see the return, what is being returned is a data frame. Now if I try to access a particular row which is unique, and if I run this, you can see a series is returned. And so in one case a data frame is being returned, another case a series is returned. So the return data type is changing, so which will of course complicate the coding aspect. Now let's talk about some of the descriptive statistics that we can perform on these data structures, data frame and series. So let's take the example of this df9 data frame here, and this is df9. Now if we want to perform column sum, we can just call df9 dot sum like before. So this is our df9, this is df9 dot sum. So we'll have column sum. You can see that NaN values have been excluded. So this is the default behavior of this method. Now we can pass on the access argument as 1, and we can compute the row sums here. If we want to change the default behavior where NaN values are excluded, so for that we can use this skip NA argument, keyword argument, and we can indicate it false. So in that case NaN values won't be excluded, and so the whenever operation is going to involve NaN will get the output as NaN. So if I call df9 dot sum access column skip NA false, so you can see the output, there are two NaN values. Similarly let's take this column means, df9 dot mean. So you can see for column 1 and 2 we have got the mean values. So this is another statistics, useful statistics. Now sometime we might want a column and row indexes of the maximum value that is there. So for that we can call this idx max method. So df9 dot idx max, and we'll get, you can see for column 1 and 2 we'll get this the index where the values are maximum. Now let's have a look at df9. So you can confirm the same, that b index along column 1 that is higher value 7.1. Similarly for column 2 the d index we have minus 1.3, which is higher value. Similarly, we have the IDX min, so we will get the index where the value is minimum. So, if I run this, you can see for the column 1 and 2 the index where the value is minimum is returned. We can also compute column cumulative sums. So, for that we can call this CumSum method and df9.CumSum and will get the output you can see along the column side the values are being summed up. Now, there is another method called describe. So, we can call df9.describe and multiple statistics are going to be generated using this particular method. So, if I run this here, you can see count, mean, standard deviation, mean value 25 percentile, 50, 75. So, all these quantiles and max value, all these multiple statistics have been printed here. We can also use the describe method for non-numeric data. So, let us say we have the series of consist of non-numeric data and we are also applying describe method here. You can see in the output we are getting count, unique elements, top and frequency. So, all those things for non-numeric data we are getting here. So, for this series object we are just we can replicate some of the repeat some of the elements here using this kind of expression here. You can see this output. Now, let us move to another important statistics, correlation and covariance. So, typically for a pair of variables are involved. So, before we go and talk about these methods, the relevant methods to compute correlation and covariance, what we will do, we will try to obtain data from certain online sources. So, for this we are taking this example of obtaining stock prices and volumes data from Yahoo Finance. So, for this we require this Pandas underscore data reader module. So, you can install this. This is the additional module not available in the Anaconda installation. So, we will have to install it additionally. So, you can either use Anaconda Navigator to find out the non-installed modules and install them, or you can use the Anaconda prompt and type this this code conda install conda space install space pandas dash data reader. So, you will get this and then you can import this module here. You can see we have imported. Now, what we will do, we will download the ticker label data from Yahoo Finance data database, online database, and what we are doing is here we are calling this function web dot get underscore data underscore Yahoo and ticker label for these for these companies, as you can see. And if I run this, and then further we can create a data frame from this data set. So, you can see just like in the R platform we used to import data from the Excel files, here we are demonstrating the same thing where we are connecting with a web resource and downloaded the data set and then creating a data frame. So, here you can see we are picking a particular particular data here and running this. So, we will get the price. So, this is the data frame for those companies. This is a time series data. So, index is time actually. So, we can have a look at the first 5 values you can see here. Similarly, for volume also similarly we can obtain this first 5 values here. We can compute the percentage changes. So, returns, and let us have a look at the lost values. So, you can see because we are looking at the lost value. So, the data is date is changed to the current date here, and then we can compute the correlations. So, whatever data frame we have just now created, we can use the core method here. So, let us say 2 column MSFT and IBM. So, in this fashion we can call this data frame, select the column, then call this dot core method and pass on the argument, pass on the particular column against which we would like to compute the correlation. So, 2 columns are required. So, you will get the correlation value. Similarly, another example for covariance here again. So, in this fashion from a data frame you can easily compute correlation and covariances. We can also pass on column name as attribute. So instead of saying returns and within brackets and indicating the column index, we can say use that column name as an attribute, returns.msft and .car. So in this fashion also we can compute. We can also compute correlation matrix. So among all combinations, so we have to just call returns data frame and .car the method, and all for all combinations will get the correlation value. Similarly, for we can also compute the covariance matrix. So returns .cob. So we'll get the covariance matrix here. Now if I want to compute pairwise correlation with one particular column, so for this we have this another method corbid. So returns dot corbid, and we'll have to specify. So what will happen, this column, the correlation of this particular column which is being passed as an argument, the IBM column, and its correlation with other columns that are present in the data frame, that will be computed and displayed in the output. So if I run this, you can see in the output. So it's like, so it is quite similar to first one column, one particular column of the matrix that we had generated. So the corbid output is similar to that. Similarly, we can also compute correlation between columns of different data frames having same column name. So one data frame having these same particular column name, the another data frame also having the same column names. So if we want to compute the correlation between a particular column, a particular column with a particular name in a data frame, and a particular column with the same name in another data frame, so we can compute the correlation. So for that, again we can use this corbid function, where we are using returns dot corbid and passing on the second data frame as an argument here, and we'll get the output. Let's move forward. Now let's talk about the unique values. So in the series, again like we have discussed before, we can use unique method and we'll be able to find out these unique values. We can sort them also, and for certain statistics we would be required to compute the value frequencies here. So for that we have this value underscore counts function, counts method. So for any series we can call this method and we'll get the counts for each of those values. Now let's move forward. Now there is another pandas function values value underscore counts that can also achieve the same thing. So we can call pd dot value underscore count and pass on the arguments here, as you can see, and this will also achieve the same output. Now there is sometimes we might be required to filter presence or absence of an element. So for that we can use is-in method. So we can pass on the argument a particular element, and we can find out whether that is present or not. So let's say series 18, and we'll get a boolean output here, and you can see wherever that particular element is present, it comes out that true is indicated and otherwise false is indicated. So we can do the same thing for multiple elements. So we can pass on as a list of elements. So next example, you can see wherever one of those elements are present, true is indicated. Now we can use this boolean output and pass on into the series or here, and only those wherever true is indicated, only those elements would be selected. So let's take this filter and select those values. Now another example where sometimes this is for the data frame. So sometimes we would be required to compute frequencies and the columns would be related. So that also we can perform. So let's take this example of this df10 data frame. So you can see we have these values here in this data frame. Now what we'll do, we'll use the apply method, and within the apply method we are passing another function, that python pandas function pd dot value underscore count. So it would be applied on each of on each of those columns. So, row label are going to indicate the distinct values of the data frame that are there. So, if you look at the output number 439, distinct values are 1, 2, 3, 4, 5. So, those are going to become output in the next code that we are going to run, d10 dot apply, and then passing on this function pd dot value underscore counts, and the values, they are going to indicate the count of those distinct values in the respective column. So, if I run this, and you can see in the output number 44440, the row indices are the distinct values of the data frame, and along the column we are getting the counts. So, 1 is present 1 times, 3 is present 2 times, 4 is present 2 times, 2 and 5 are not present. So, that is how it's like a frequency that we have got here. Now, there are some of the NA values. So, that is essentially means that those those elements, those distinct values are not present. So, we can fill those NA values with zeros. So, for that again we can use FillAny method and pass on zeros, and the output would be modified. So, with this we have been able to cover Pandas package, and in the next lecture we'll start another aspects of the text mining analytics, where we will be focusing on how to how to work with data, import, export, and process and transform. So, now we'll more focus on those aspects and how we can perform the same thing in the Python platform. So, we'll talk about that, we'll start that discussion, and let's stop here. Thank you.